Today we are finding line segment lengths, specifically horizontal and vertical line segments. You'll be working on finding diagonal line segments when you get to geometry. Here we have a graph where our line segments are already graphed, and that's going to make it significantly easier for us. One thing you want to check when you are finding the line segments of line segments that are graphed is make sure that your intervals are going up by 1 every time. Here they are, but you definitely need to make sure that that's always the case. Let's start with finding the line segment of line segment MN, which is right here. Since this is already graphed, we can just count our sections. Here we have 1, 2, 3, 4. So line segment MN is 4 units. We use this line above the letters to indicate that it's a line segment, but I don't want you to worry too much about that. Line segment MN is 4 units. Let's go on to RS. Line segment RS is 1, 2, 3, 4 units also. It doesn't matter if your line is vertical or horizontal, you're going to count your graphed line segments the same way. Now let's go on to line segment PQ. Line segment PQ is a little bit longer. Notice it's going from the negative x values to the positive x values, but because this is a graphed line segment, that doesn't really matter. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So line segment PQ is 9 units. It's that easy when you're finding the length of line segments that are already graphed. Here we're asked to find the line segment of a line that has not been graphed. And one option would be to graph it, but that's going to end up taking a long time if you have to graph every single time. So remember, we're only right now focusing on finding line segments if our lines are horizontal or vertical. So before we figure out the length of this line segment, we need to make sure that it's either a horizontal or vertical line. So again, how would you do that without graphing? Well, we're going to look at our x values and our y values. So we're going to take our x values and then take a look at our y values. If your x values are the same, then your line is vertical. If your y values are the same, then your line is horizontal. If neither of them are the same, then your line must be diagonal. You're going to want to make sure that's in your notes. So here, looking at our x values, we can tell our x values are the same, and therefore we know that this is a vertical line. If our y values were the same, we could say it would be a horizontal line, and if neither are the same, it must be diagonal, and we don't know how to find those line segments yet. Now that we know it's a vertical line segment, we need to figure out the length. When we are figuring out the length, we're only going to take into account the y values. We don't need to worry about the x values that are the same. We're going to find the length by taking the absolute value of the bigger y value and subtracting the absolute value of the smaller y value. Remember, we're always going to go bigger to smaller because when we talk about distance, distance can't be negative, so we might as well just do the bigger one minus the smaller one. And again, because distance can't be negative, we want to make sure we're taking the absolute value of both of our y coordinates. So in this case, the absolute value of 15 minus the absolute value of 6. The absolute value of 15 is just 15. The absolute value of 6 is just 6. So we get 15 minus 6. Line segment AB must be 9 units. Here we're given another problem where we need to find the length of a line segment. Here our y values are the same, so we know this must be a horizontal line segment. When we're finding a horizontal line segment length, we're going to subtract the bigger x. We're going to take the smaller x value, absolute value, away from the bigger x value's absolute value. So in this case, it's going to be the absolute value of 18 minus the absolute value of 5. So the line segment RS must be 13 units. Here's an interesting situation. So I'm asked to find the length of a line segment where my x values are the same, so I know that I have a vertical line. My y values, I have one positive y value and one negative y value. You really have to be careful when you're looking for the length of line segments if you have one positive value and one negative value. This one's going to be a little trickier. because this line segment is going to cross the y-axis. To find this line segment, we're going to find the line segment that goes from, this point to 0, and then add the line that goes from this point to 0. Let me show you what I mean. Here I have my line segment. Not very pretty, but it's my line segment. What I'm going to do is I'm going to find the line segment of this length, and I'm going to add to it the line segment of this length. Oops. Because my graph is crossing this x-axis, I need to add the line segment that's above the x-axis and the line segment that's below the x-axis. It's actually a lot less complicated than it might sound. I'm just going to take the absolute value of one of my y values and subtract 0, and I'm going to add to that the absolute value of my other y value and subtract 0 also. So the line segment of line CD is going to be 7 units. Above the axis is 5 units, and below the axis is an additional 2 units, for a total of 7 units. I know this video had a lot of information, but we will be practicing in class tomorrow, and if you have any questions, email your teacher.